Not you stress. You're only here.
So the essence of the distance, first off, distance cannot be less than the magnitude of the displacement.
Okay.
You start at a particular spot, you go out to some other location, and then you turn around and you come back. So displacement is gonna be this distance right here. That's the displacement for the whole journey right there. The distance is how far you go there and back. It would include the whole thing. So if this is 100 meters to here, and this is, let's just say 30 meters, well, that meant I went 100 meters out, and I end up 30 meters back, so it means I had to have traveled 70 meters back.
And I get that, I just,
Okay.
for distance, would that be the one, I mean, the only thing I can remember using for distance was the one where it's at rest. But this one isn't at rest because it starts at 62 meters per second. This one, that's the only one I can recall.
Right, how far did the object travel from the beginning of the problem to its stopping? Oh, I know.
No.
At what time did it stop? And then you figured how far it went when it stopped. And so that would be,
Well, the 100 meters or whatever.
Oh, would that just be plus?
would that be just plus?
Would you just add them? Because like you said,
Well, it's,
oh,
so
no,
the answer
'cause
to
it's
12
part
will tell
of
you
it.
just what this number really is.
Okay.
The answer to whatever the displacement question was gives you this number.
Mhm.
And so the difference between that and that is what you're gonna add to
Okay.
the 100,
That makes sense.
or whatever the number is.
I'm sorry.
100 is the displacement. No,
No,
30 is the displacement.
30 is the displacement in
100
this
is the
example.
distance.
It's not in our thing then. Proof. It's 170.
170 is our
Displacement.
displacement.
Okay, so that's 170 instead of 30.
Uh-huh. But for 12, that's how much it traveled to the stopping point.
That would, the answer to 12 is the real number here. I just made up 100.
Uh-huh. So then, okay. Hold on. So it'd be 213.
I guess coincidentally, that's the same number as the displacement in the real answer. So why don't I just make that 40? 40. Bailey, you have the look of someone who is going, I have no idea what you're saying or writing. That's the look. But you're wearing a mask, so it should
No,
be
it
completely
is.
disturbing.
I understand the displacement part, but how do I get distance?
Right, so the answer to number 12, the question for number 12 was, how far does it go before it stops?
Yes.
Okay. So,
It says at the time in the previous question, though.
right. And the previous question was the time it takes to stop.
Yes.
Alright, so whenever, it's a one-dimensional problem, whenever I turn around, I have to stop in order to turn around.
Yes.
Okay, so, I guess, so then the answer to 11 was the time it takes to get to here. Answer to 12 was the actual distance or displacement it takes to get to here. And the answer to one of the other ones was how far do you end up from where you started? Oh, alright, so we can do it in terms of, let's do a different unit of measure here. I'm gonna start here. I'm gonna end up 3 steps away from where I started. So we'll just establish 3 steps. But I'm gonna be walking back and forth. So I end up 3 steps from start. I know that I am going to travel, we'll just say 7 steps from where I started before I turn around. So I travel 7 steps before turning around. That's the word turning. closer to it. All right. So, 1, 2, 3, 4, 5, 6, 7. I stop, I'm turning around. I know I'm gonna end up 3 steps from where I started, so how many steps back do I have to take? Yeah, so how many steps total am I taking?
7 plus 4. So can you come check my math and see if I did it correctly? So this is the number that I got for this, minus the displacement, plus what I got from there.
Some of those numbers seem familiar. Yeah, I mean, if that number is right, then, okay, then your process is right. Yeah, okay.
I feel what he's saying, but I don't know how to apply that.
So we have the displacement.
Yeah.
And we have the distance for how long it took to get to the stop.
That makes sense, I like that.
All right. Other questions well, they're working through that. Any other questions at the moment? Ariana?
For the master set that's due today, I have some questions.
Okay.
I'm trying to decide what I'm gonna ask. For question 8/14, it was like the same question, but you just
It
had
was.
you just had one difference. It was like A was period and for 8, and A was frequency for 14.
Oh, I was thinking, I thought I compared them side by side, they were.
This is period and this
Oh,
one is
okay.
frequency for A, but the rest is the same.
Oh,
So how did we get that time?
I only answered part A.
yeah, and for the rest, you can just say C number 8.
Okay.
Okay, but I do have some questions
Maybe that's what's
not
not.
about A.
Oh,
What 8 is?
I have a question. I have test corrections, the lab due today, and the master set. Do you just want me to put it all in that pile, or do you want me?
No,
okay.
all in one stack works for me.
The master set's due at the end of the day.
Yeah, I was just gonna give it, I'm done. I was just gonna give it to you tonight. Or do you wanna submit it online? The
Master set's online is a little bit more convenient for me, but,
Okay, I can do that online then.
but if you've got a paper copy and you don't, and it's not 100% guaranteed that you'll be able to do it tonight because of other obligations,
Okay,
I'll take paper, but.
okay, thank you.
Okay, so about my question, how do you calculate, the speed of the wave?
There's 2 ways of calculating speed, so it depends on what you're given. I can't remember specifically for that one, but you've got the speed for any harmonic wave or any oscillating wave, doesn't have to be a harmonic, but, which is the frequency times the, I guess, wavelength times frequency, that's one of them. So if I'm given that information, I find it that way. The other one is you find the speed from the square root of, if it's a one-dimensional, close enough to a one-dimensional problem, it's tension over the linear density.
Okay,
I think on those, you find the speed initially this way, you find the tension, and then I think the last question is, what is this
linear
one?
density. Yeah, could you show me how to calculate the linear density?
From this information or from other information? Because linear density can be found 2 ways as well.
In the way that you want us to for this question?
If I'm remembering correctly, it's, you have a speed, so if I have a frequency of 100 hertz, and I've got a, let's see, that was 2 fixed ends, that was a string vibrator, I believe. And let's make it the first harmonic. So if it's the first harmonic, and this distance is given to you of 3 meters, it's huge. Yeah, the amount of tension you have to put on the string for this one is enough to break loose, at least. I don't think I was at 3 meters, I think it was at 2 meters when I was filming it for the online version of this. And I kept breaking it because I had 3.5, 4 kilograms hanging on the end of it. Anyway, so if that length is 3 meters, that's a half of a wave, because a full wave looks like that, except more symmetrical. So my wavelength would be 6 meters. My frequency, I just made up the number of 100 meters, or 100 hertz. So the speed of the wave would be 6 meters times 100 hertz, or 600 meters per second. So once we have the speed, then it's a question of, I think there's also tension, because I gave you how much mass was hanging off the end of the string, because this is hanging off of a pulley here, and I had a certain amount of mass there. If that's in equilibrium, the tension has to be equal to the weight of the object. So let's just make this 4 kilograms, why not? And therefore, my tension would be equal to my weight, which is mg. So 4 times 9.8, 39.2 newtons. And now it's a matter of set them equal to each other, because I know what my speed is now from the first information. I know tension, and I have only one unknown. One equation, one unknown, math people are in. And so you have 600 is equal to the square root of 39.2 divided by the linear density. And now it's a math problem, and granted, it's a little bit more sophisticated than some of the other stuff, and again, I've had students physically shake at having to do math. But this is also one part of one question of many questions, so it was not a huge impact if you could not do this. But first thing you need to do if you're solving for an unknown is to start getting rid of all the stuff that's holding it down. So we got a square root here, let's get rid of the square root by doing the opposite, square both sides.
62 minus what?
And so 39.2 over mu is 600 squared, which is 360,000.
6.8.
Now it's got two fractions equal to each other. Multiply the diagonal, you know, divide by what's left over. So mu is 39.2 divided by 360,000, whatever that is.
What's negative? So it's
Whatever that is.
And what's the unit for linear density? Is it kilogram meters? Or
Per.
kilogram per meter?
Per meter. So what's the actual, did you,
The 7 is supposed to be an 8, but other than that, it's correct.
that's how you, I think she was asking about question 8.
Yeah.
And
And
so,
so-
I'm using different numbers here than what's in the problem, but it's the process.
And you give it frequency here, is the frequency, does it change because of the weight at the end, or?
The frequency is driven by the string vibrator.
So whatever that is, that's the frequency?
Right.
Okay. And to find the period is equal to 1 over f?
Yes.
Okay. And that's expressed in seconds?
The period would be in seconds,
Thank you.
or inverse hertzes if you want to, but that's just a second.
Okay.
I don't want to
Find the number of
that's
wavelengths
displacement.
that we didn't have last time.
And we're looking for.
Define the number of wavelengths.
Yeah, the question is,
But I don't know.
it says, how many, what is the wavelength of a wave? Oh, sorry, that's a different thing. The wavelength of a wave, we just take the 1.5 or however much the wavelengths are. I don't know if I'm saying this right.
Right, so you take the number of wavelengths and divide by the distance. All right, sorry,
You divide the distance.
this
by
distance
the
divided by the number of wavelengths.
Distance divided by wavelength.
Excuse me? Can I ask a question?
Sure.
Okay. In what case would you use distance equals average speed times time?
If you're going in a straight line.
No, not necessarily. I mean, average speed is always distance over time, or distance is always average speed times time. So if I ask you what's the average speed, I would use that equation.
But you wouldn't use it to get the distance?
In that particular problem to which you were referring earlier, no, because you don't know what the average speed is. You have to
Okay.
get the distance in order to find the average speed.
Okay, I see what you're saying.
Or
So
if
it
you're
has
trying to
to
find
be
the average
that one.
speed in a different way, it's far more complicated.
Okay. So even though it's asking for how far did the object travel from the beginning of the problem to its stopping at the time in the previous question, even though displacement is for displacement, could you still use that?
You can use the distance and displacement almost interchangeably, other than distance is always a positive number, if you're only traveling in one direction. So from the beginning of the problem to stopping, you're only traveling in one direction.
Okay,
But once you turn around, suddenly distance and displacement become,
very different.
yes.
So,
Yes, you can,
so for 12,
yes.
okay. Okay. So, okay.
All right, so at this point, there's sort of several questions that are out there, and just wanna make sure that they've been answered. So Ariana, was your question answered?
Yes.
And Bilha, was your question answered? Okay. And I guess Rihanna, you're still asking questions?
Oh, yeah.
Okay.
So you said to find the average speed, I need the distance. So I would just kind of like reverse the distance and the time, and then I see what you're saying. I'm good.
Okay.
Okay.
Other questions at the moment?
Yes.
Is that a yes?
Yeah, I have more questions about the master set.
Okay.
For question, 11, I wasn't sure if I, calculated it, or I guess, wait, let me make sure I do have a question. Is that right, how I calculated the wavelength?
So 11, I give you the long hollow tube, okay, creating the third harmonic. And the wavelength, so once it's the third harmonic, you establish the number of wavelengths. And then you would,
Which is 1.5 wavelengths. Or is that the question? Yeah.
okay, yep. And then it would be the length divided by the number of wavelengths.
Which is, I think what I did.
Yep, okay.
Okay, so that's fine.
It seems like it.
Okay, thank you.
Other questions at the moment?
I have
Yes.
just a small question. When you brought the spring thing out, and like Brianna pulled on half and you pulled on half, and like there, like, say there was 100-pound weight on this side and 100 grams on this side, what would the reading in the middle be? Like, I was confused on that a little bit. Okay, so say something's hanging from the ceiling,
Okay.
and you're applying a force downwards, would the ceiling be exerting the same force on you? That was just
How,
like,
how nitpicky do you wanna be on this one?
well, I just reviewing like chapters 2 through 5, and like that one kinda didn't make sense to me.
Alright, so I have something hanging, so I've got ceiling right there, I have something hanging from the ceiling, and I've got a mast there, and I'm pulling down on it. Is
Yeah,
that-
correct.
Okay. So, if we think about the forces acting on the mass,
Mhm.
there's this tension acting up because of this rope. And then there's the rope that has a tension acting down there, acting up there, and then the ceiling has a tension acting down. technically, the ceiling is not pulling up on this, but indirectly it is.
Mhm.
Those values, in an ideal situation, those values are the same. If we brought a little bit more reality into it, there would be a difference in it based upon the weight of the rope itself.
Okay,
In an ideal situation, we ignore that.
okay,
The mass, so that's the mass right there.
right.
The mass also has a weight acting down, as well as a different tension from me. I'm pulling down on it, so it's a different subscript. If I drew a picture of me here, then there's this tension too acting up on me. And so that's the force diagram involving the mass here. So
You just changed the time.
the force that I'm applying is not the same as the force here because there's this other weight involved.
But it's in equilibrium, so wouldn't it be the same amount of force since it's not moving?
It's the same thing, you just changed the time.
It's an equilibrium, which means it's not accelerating.
Right.
Static equilibrium, it's also not moving. This tension here would have to be equal to the sum of those two.
Okay.
In some situations, if the weight is small compared to what these forces are, we can go, you know what, close enough, we're gonna ignore it.
Okay.
But in
So-
reality,
You wanna see what I do?
the force that I'm pulling down on it plus the weight of the object would be basically the tension
Okay,
that the ceiling is feeling.
He said that.
okay,
So the tension in the rope above the weight is different from the tension in the rope below the weight?
Correct. Because this is being caused by me, this is being caused by the rope.
Okay, so
They're
the
two different
first
sources.
tension is, so the tension from the ceiling onto the object is caused by the weight's object and how hard you're pulling.
Right.
And the tension that you're pulling is just for fun?
The tension I'm pulling is,
yeah,
I said just for fun, just whatever you want
Yeah.
it to be? Okay.
okay, thank you, that answers my question.
okay.
If there were two masses that were the same weight, would it be this one, the top one has double the tension of the bottom one?
So I'm not pulling on it anymore, but you have a weight hanging
Yeah,
underneath.
And it's the same weight as the one above
So
it?
it's some mass there and equal mass there.
Yeah, the tension in the rope above it would be double the rope, the tension of the rope between the two?